Alright, I want to make a quick little video here. I hadn't posted anything for a couple weeks, and so I just want to make this video, and I had to get through this job quickly, so I couldn't do a full-fledged video on it, but I thought it might be worth seeing anyway. I took a bunch of clips with the iPhone as I ran the part and kind of talked about what I was trying to do with the setup and everything. And the reason that this job even came around to me was because the customer said he was trying to get some people he normally deals with to do it, but they couldn't handle the size of the part on their vertical mills, which is a issue with vertical machining centers, is that they have generally more x-axis travel than y. And in order to go around this 32-inch ring, you have to go to a quite large vertical mill to do it, but on a horizontal mill, the work envelope has more space or more travel in the y-axis, and it's almost square in its travel range, and so you can go around parts like this a little easier, but you have the difficulty of fixturing with the part. And so this video kind of shows a simple, crude setup almost, just to get the part done, and not super high feed rates or anything like that. You know, I'm not trying to break any records here, but you just got to get one part done. So hope you enjoy the video, and let's get to the machining part of it. I'm machining this disc out of this 1.25-inch aluminum. I put some brown paper, a couple layers of this brown wrapping paper underneath it, so that I could come right down to the face of this pallet. Well, this is my fixture. I use flat. Normally I clamp it flat on the pallet. It's got T-slots in it, and I'm using it clamped vertically on the tombstone here. You can see the T-slots there. And I need to rough off this outside part of this plate, and I need to come down to where I parted off, but I don't want to hit that. Although I'm going to reface it, so I'm not too concerned if I scratch it, but I don't want to hit it with the end mill. So this plate's only about 10 thousandths thicker, maybe 10 or 15 thousandths thicker than the finished size, so I have to be kind of careful here. Here's the second pass around there. I'm going to take 4 passes to get down to the 1.25-inch depth, just because I don't want to push on it too hard. I don't know how good a grip. I've got those 4 cap screws in the middle and the clamps on the outside to catch the pieces when they drop off, hopefully. We'll see. All right, I cut this, and I'm trying to be real careful not to hit this this table-like base thing. And according to this, I got about 10, maybe 12 thousandths more to go to actually part these off. I've got to set it in anyway, because I want to skim the face off here. The part, the customer said I could take it below 1.25 inches, but right now the stock is, if I could do this, kind of hard for me to do this and hold the phone at the same time. The stock is about 1.265, so I could set the fixture offset in a little bit more. I want to be able to break these parts off around the side here, and then I'm going to face the whole thing and do a little bit more machining, put some holes in it and such, and then take it off and flip it over and put it back down on this base thing and skim the ring. The ring is about this wide, so I skim that area off till it cleans up. The customer said he just wants it to clean up. The 1.25-inch dimension isn't real critical, so I want to face this side off. I want to take about maybe a little bit less than 10 thousandths. So I think I'll set the fixture offset in maybe about 8 thousandths or so. I don't want to hit the table, like I said. I put the 2 layers of that brown paper under it, which are 3 thousandths thick each, so that should give me about 6 thousandths leeway as far as hitting the table too with the end mill. Okay, here we are in a spree. I'm going to take this rough OD pass, and I'm going to just make it one pass going around here. So we go over to strategy. I'm gonna just go one pass all the way to depth. That should be it there. You can see it. And I'm gonna reprocess the code and send it back up to the machine like that. After I do this, I'm gonna try to break those pieces off of there around the sides, and then we're gonna face it and finish the OD, and rough halfway down here, chamfer the OD and the ID, and then do the various holes. And then when we flip the part over, we can stand off a little bit, because I'm going to put about a 10 or 15 thousandths chamfer on these corners, so we don't have to hit the face of the pallet. All right, I reprocessed the code, so it's only going to take one pass around there at the full depth. So we're going to send it back up to the machine. So I got to select this up here to send. It's trying to send it. Now I got to come over here and select one for the main program, and then just push input down here. It's inputting the code here through the serial cable. I got to wait for it to finish loading the program. It's the only way I can get programs into this particular control. It doesn't have like a network connection or anything like that. So I took our passes, like I said earlier, around here, and we're just about parting this thing off. Got about 6 thousandths to play with on the paper thickness. I set the program in another 5. So this was about 10 or 12 thousandths thick up here still. So I'm going to set the fixture offset in about 5 thousandths, and we'll see where the face mill cleans that up when that happens. And I'll keep setting the fixture offset in until it kind of parts it off down to that paper. All right, I stopped it just to take a look and see where I'm at. Let me let it run down in there a little further, and we'll see where we're at. I might be able to go just a hair deeper. I think I'm going to set the offset in just a little bit more. It's not quite breaking through. Try it one more. It looks like it pretty much, you can see the paper. I don't know if you can see it. It cut into the paper right here. But it didn't really break through totally, but I think I can break these off. Should be able to just break that off now. So I'm going to send the pallet out, and we're going to break off the pieces, and then face the middle part with the face mill. But first I'm going to change to the face mill because of the way this tool changer works on this machine. It's easier to restart it if I do this. So if you push feed hold in the middle of a tool change here, it stops at the end of the tool change on this machine, which is kind of handy. So now I can let it bring the next tool up into the arm. You can hear it right there. When it finishes that, I'm going to hit reset, and then we're going to send this out on the pallet change. Okay. Now, I'm going to go back to our MDI. MDI complete, MDI. We're going to send the pallet out. It'll just be easier to work on it out there than to mess with it inside the machine here. And grab this. We can rotate the pallet around. You can see the paper I put underneath just a couple layers, so that I have about 5 or 6 thousandths of paper thickness to deal with there to so I wouldn't hit the face of that You can see the face of it right in here a little bit where it actually broke through. It broke the material up through. Wanted to do that here a little bit as well. Okay, let me get my gloves on and take these clamps off, see if I can break that off. All right, that didn't go too bad. I was able to break it off, not too much difficulty. This is real thin right here right now. You can see. Here it kind of broke through. It didn't even hit the table, so the paper was doing its job. Now, I take that down and send it back in and do the facing operation. Pliers, and I kind of bent that back and forth a little bit with my gloves, and I pulled off the extra piece of material, just like this, that was surrounding the part so it doesn't get pulled up into the finish cut. And now we're going to send the pallet back in. Oh, first we got to position the pallet the right direction. It has to be able to catch on that dog there. Okay. Now, it should work when we push the finished button. Cycle start. And should grab onto the pallet. Send it back in. Okay. Now we're going to restart it at that tool and face the face of it. See where if it cleans up. Looks like it's cleaning up all right. I don't really have time to do a full-blown video with all of this stuff. I got to get this part done, and I was just taking some shots with my iPhone here. Maybe I can cobble this into some sort of a video. It'll work pretty good. Let's see what this thing. Get some of this coolant off of here. Cleaned up all the way. The reason I'm facing this whole surface is when I flip it over, I've got to clamp it down again with these 4 screws and finish milling the ID to break out that. But before I do that, I can clamp it in the 4 places right here on the corners so that the outside ring doesn't just fall off of there. And these 4 screws will hold the inside piece from moving around when it breaks through. It's actually going to start way over here to mill the ID. Finished the OD and just roughed halfway down on the ID. I'm going to chamfer these 2 corners and put the rest of the holes in. So there's no actual holes or anything to put in the other side, so it's not too critical that I get it aligned perfectly in a clocked, I guess you might say. I just have to get the center of the circle and then face it and chamfer the ID and the OD corners. So it's not really a difficult part to make, but the beauty of a larger horizontal machining center is that the travel range is almost square. This machine has 1,000 millimeters by 1,250 millimeters of travel, so I can go around a 32-inch diameter or even larger a little bit. And the guy that brought this over was having problems because nobody had a machine big enough, because you got to have quite a pretty good size vertical milling machine to go around a 32-inch diameter with the cutter. It means you might have to go around about a 33-inch diameter depending on the size of the cutter you have and how close you are centered. And you actually have to go up to a pretty large machine to get that much Y-axis travel. But on a horizontal mill, because its travel is greater in the Y-axis than a vertical mill, usually it is, you don't have these issues, and the work envelope is almost a square in shape. And so it's actually a better machine to do this kind of stuff on, but it's harder to fixture it. So it has these advantages, and it has these drawbacks of fixturing and you're holding weights up vertically, and it's kind of hard to get it all clamped down. And in this case, I have this base that I use normally. I clamp that, like I said earlier, down on the pallet, and I use it to set up parts with clamps holding them down on the pallet. But in this case, I've drilled and tapped 4 holes in the tombstone so I can mount that thing up on the tombstone and use the T-slots in it, which you can see right here, the T-slots that it has, and regular tie-down type things. So I didn't want to make a bunch of stuff to space this out, so I had to be very careful that I didn't mill into the table here, and that seemed to work pretty good. And when I put the chamfers on both sides here, when I flip it over and I'm going to cut halfway through and break this metal piece out, I don't have to come all the way down to the table's face with the end mill. I can stand off 10 thousandths or so and finish the ID and the OD. Well, the OD's finished. All I got to do is finish the ID, and I can do that and not hit the table. You can see the chamfer looks larger. On the ID because of the stock that's still on the board. Here's what we got after putting the holes in. Now I just drilled all the way with the tip of the drill down to where it met the 1¼ inch depth. And then I came in with an end mill, you can see in there maybe, and milled the bottom, flat bottom, the holes right down as deep as I could go. It didn't break into the paper, but it's got to be only a few thousandths from doing that. So that finishes the holes the way I had to because of the setup. I could have just drilled all these holes. They were good drill sizes, but of course you can't drill into the pallet base. So now I'm going to flip the part over and clamp it down with these 4 screws on this milled face. That's the reason I had to mill the whole face. And when we do that, we'll face just the ring with the 3-inch face mill to finish it down to thickness, and chamfer the ID and the, well, actually we'd just chamfer the OD at that point. Put clamps on in these locations where I can get to the T-slots on the pallet base, and then finish milling the ID and chamfer the ID. And then the part should be complete. I'm not going to worry about doing any kind of chamfers on these holes. I'm going to do that with a deburring tool because I don't want to line up the timing of the holes and everything to do that for the second operation. So I just have to clamp it down, and then I can probe the outside and to put my fixture offset right on the center of the part. Here's our next setup to start with. We've got the 4 screws holding it down onto the pallet. Now we're going to have to probe the center and the height again, and then start our program, and we'll just run it at the first height. This still is about 6 or 7 thousandths thicker than 1¼ inch. And I'm just going to run it at whatever the depth is probed in the center there, and we're going to see what we end up with and what cleans up, and then I'd make the adjustments after that. Here's the probing cycle we're interested in, except we got to make a few little edits here. Got to change this to a 2 point, and the diameter of 32.0, and a Z minus point. We'll go 7.5 end of block, and then we're going to do this cycle. We're going to skip this one because we don't want to set the Y. This will set the X and Y because it's probing the circle, and then we're going to go down to this one and probe the Z. Going to change to the probe here. Okay. Now I'm going to probe I marked the center of the circle here. I'm going to probe it. I'm going to jog it down to there, and then I'll video the probing cycle. Probe the circle first. So it should go 3/4 of an inch down from there. Take the first point, and it's going to take a point up in Y and then go across an X and get the X dimension for the center of that circle. And we're going to go over in X now. And like I said, I'm not worried about the timing of the holes because I'm not going to do anything with the holes. That's why I did the holes all from the front side. So that's going to be probing this. So if we go over to the work offset, we should see these two numbers change when it finishes. Okay, so that's the X and Y zero. Then we're going to hit reset here, and we're going to go to this line in the program. Here, push input, MDI complete. It's at the top of the screen. This is probing the Z. So we push cycle start, and that's going to probe down in Z. Like that. Okay. Now, we hit reset again and go back up to the top of my MDI screen here, input, and change the probe out of the spindle. This machine constantly runs the probe while it's in the spindle in connection with that transceiver deal, and it'll run the battery down if you leave it in the spindle. So I always change it out after I finish my probing manually. So we should be ready to run this, and I'm going to just run it once just to see what it does at that level. I know that that's set too high, and I'm just going to run the face mill that's facing off the top there and see what happens. I turned the coolant off so we could see what's happening. It's just running the finishing face at the surface that I probed. First pass. I know this is going to be too thick. It may not clean up in all the way around. You can hear it hitting those holes. See the holes? You can kind of see them. I don't know if you can see that or not. You see the holes there? It didn't perfectly clean up. I expected that. In fact, I don't expect it to be perfectly parallel here, because clamping down to that paper will cause distortion when I'm tightening these screws with that paper between, and it'll cause some distortion in the plate. So it only has to be plus or minus 5, so it'll be fine, but it probably won't be perfectly flat. I expect that. So we're going to measure the thickness at the 4 places on the ring we can reach with the calipers. And we'll see where we're at. You can see how thin it was here. See, I can just punch. Those may come out when I get it down to thickness. Those I don't know if you can see that, the holes. And it'll probably clean this up when I get it to thickness too. See, it didn't quite clean up right here. Plate might not have been perfectly flat too when I clamped it down to the table, and then I kind of forced it down, and then I released it. But it'll probably be good enough for the purpose here. I faced it off. I had to set it down about 7 thousandths to get it to thickness I wanted, and it cleaned up all the way around. Now I've got to put these clamps on here and clamp it in the 4 places I can clamp it. And I may put a C-clamp across here too, but I really can't do that on the top and bottom. And I might even be able to fit one in here. Let me experiment with that a little bit. But anyway, I've faced it and I've run the chamfering tool. Now I've got to put the clamps on there. This is what I ended up with, the clamping setup. And it's got to clear this holder here. And I think we're going to be all right with this distance And this might be kind of close here on the 2 clamps. I think the tie down thing should be all right. We're gonna see when we run it. So this is the last roughing pass. And I don't know if you can see it, but I cut the plug out of the middle of the part. Then we'll do the finish pass and chamfer the ID. Everything seemed to clear all right with the clamps and everything. I shoved these out just a little bit more, just in case, but it cleared easily. We got the ID finished. Probably can't really see, but you see and we didn't hit the table with the end mill. And now the last tool just to chamfer that bore, and except for some deburr work, we're done. So that's it. I gotta punch out these, I punched these out, I could reach them. But I gotta remove the clamps, get to these. There's a couple here I can get to. Here. And then just deburr everything. And we're finished. By the way, I don't use that coolant. I use this coolant here.